Hello friends, so today in this video we are going to solve a question which was asked in GATE 2011, right? And the question is, a silicon PN junction is forward biased with a constant current at room temperature. When the temperature is increased by 10 degree Celsius, the forward bias voltage across the PN junction, and the options are A increased by 60 millivolt, B decreases A increased by 60 millivolt, B decreased by 60 millivolt, C increased by 25 millivolt, and D decreased by 25 millivolt. Okay, so to answer this question, right, we need to obviously understand the basic of IV curve and the dependency of IV curve to the temperature, right? So let me just draw the basic IV curve of diode. So right, so this is the basic IV curve of diode that we know very well. So the basic diode curve look like this. Okay, so this is the basic diode curve which look like. So this is your diode current, this axis is ID, this is VD, right? So this point where it start increasing rapidly, or say measurable, that is called as cut-in voltage, right? This is called cut-in voltage. And the point where there is no current at all, that is called as cutoff voltage. In some book they mention cut-in voltage and cutoff voltage as the same point, right? So it's almost negligible. This gap is almost negligible, very less, so we don't treat these two value as different, right? So okay, so this is the basic IV curve of a diode, which is exponential, right, non-linear. So you have cut-in and cutoff voltage, right, ID and IVD voltage, ID current and VD voltage. So now, okay, what happens when we increase the temperature? Okay, so let me take another page. Okay, so what happens when we increase the temperature, right? So let me redraw this figure in terms of temperature so that we could understand the temperature dependency very clearly. So okay, so this is the diode curve in forward bias when temperature is say some amount. This is temperature 1, right? There is no specific this. So this is temperature 1, and this is for the reverse bias, similar. And now let me see when, okay, now we increase the temperature, right, further. So this is the curve. Okay, so let me just, so this is the temperature curve. This is the ID, this is the VD, right? This is temperature 1, temperature 2, temperature 3, and remember this temperature 1, right, is less than temperature 2, temperature 2 is less than temperature 3. So basically temperature 3 is higher than 2 and 2 is higher than temperature 1. So now in condition 1, let us consider first, right? So the first consideration is voltage is constant. So if voltage is constant, so let me say voltage is somewhat here, this point, right? I'm considering this voltage is constant, and constant voltage is at this point. So now let me see the value of current, right? So what am I going to do is I'm going to just see the current value. So okay, so across this, so this is your current ID for temperature T1, and this is for the temperature T2, and similarly this one is your current for temperature T3. Okay, so this is your ID1, right, at temperature T1. This is your ID2 at temperature T2, and this is your ID3 at temperature T3. So this is the situation number, or the condition number 1. So from this condition you could clearly see that, right? So what is the conclusion? So conclusion is, you can clearly see that as we increase the temperature when voltage is constant, and as we increase the temperature, right, as we increase the temperature, so this arrow is indicating the increment in the temperature T1 to T2 to T3, right, and this one is and this one is the indication of the change in the current ID. So here you can see that as we increase the temperature, right, the current also increases. So as we increase the temperature, the diode current ID also increases. So this is our important case number 1, when voltage is constant. Now let me take case 2, right? Now at this situation, what I'm going to do is, I'm going to constant the value of current. So this time I is constant, right? So some point somewhere here, right? No, I mean, I'll take some other color, so the black would work. So okay, at this point the current is constant, right? This point current is constant, and the voltage across it is this point, this and this point. So this is your V1, obviously across T1. This is your V1, this is your V2, and this is your V3, right? This is for the temperature T1, this is for the temperature T2, and this is for the temperature T3 when your I is constant. So as you increase the temperature, what is happening? The voltage, right? Voltage is basically at T1, this one, T2, this is voltage is what? Reducing. V is actually reducing. So the conclusion you can make is, as you increase the temperature, right, when your current is constant, as you increase the temperature, right, your voltage, which is VD, is reducing. So this is the two main, or this is the two important conclusion you can make by this IV curve of diode. So in quantitatively, what we say is, for the case 1, when voltage is constant, right? So in forward bias, what you see is your current become doubles, right? Current becomes double at every 5 degree centigrade. Similarly, in reverse bias, your current become doubles, because current is also increasing in the reverse bias, right? So as you can see that this is for the T1, this is 2, and this is 3. So current is also here, in this case it is increasing. So at reverse bias, as you increase the temperature, current becomes double at every 10 degree centigrade, not 5, every 10 degree centigrade. Similarly for the case 2, so this is for the current. Now what about the voltage? So for the voltage, when you increase the temperature by 1 degree, right, when you increase the temperature, so your voltage decreases, right? Your voltage decreases 2.3, right, to 2.5. In some book it written as 2.3, some book it is 2.5 millivolt per 1 degree. So your voltage decreases 2.3 to 2.5 millivolt per 1 degree centigrade, right, for silicon, and 1 degree your voltage decreases around 2.1 millivolt for germanium, for the germanium. So right now for this question, to solve this question, the important thing that we need to focus is this thing, right? Because it is given that by increasing the temperature to 10 degree, right, what would be your voltage? Your current is constant. So at room temperature it is 2.5 millivolt, right? Voltage is VD is, and your VD after 10 degrees Celsius would be what? 2.5 into 10, which is equal to minus 25 millivolt, right? Because every 1 degree it increment minus 2.5, and now it is given 10 degree, so 2.5 into 10, which is minus 25. So the correct answer for this question would be 25 millivolt, and minus sign indicates the decrement. So let me go to the question. So yeah, so the question here, you can see that forward bias, right, constant current, main thing, and increment by 10 degree. So what would be the forward bias? What is voltage? They are asking voltage. So the voltage, right, forward bias voltage at increment of 10 degrees Celsius would be decreased by 25 millivolts. So the right answer for this question would be D. Thank you.